Hi Year 7 and welcome to Lesson 2 for this week. Now today we're going to discuss the method and then you're going to design a method for me for your experiment. So we're going to start by talking about what the experiment is going to look like and how you can do it in your own house. Now all of your methods are going to be slightly different depending on the materials you have at home. So, if we look at what the general idea behind this experiment is, we've got a surface and a block sliding down the surface, and we want to see what lubricant reduces the friction between the block or the object and the surface that it is sliding down. So, I'd suggest probably the easiest way to do this experiment is have a kitchen tray, like a baking tray, and a small object. Okay, could even be some cutlery like a spoon. What you then do is put that object at one end of the tray, you tilt the tray to a certain level, and then time how long it takes that object to travel a set distance on that tray. Okay, once you've done that, you're then going to repeat that experiment twice. You're then going to start changing the types of lubricant on the tray. So you might want to test water, you might want to test oil or soap or butter or ketchup. Let your imagination run wild. You can test lots and lots and lots of different types of lubricants. Okay, but the idea is that you cover the tray in that lubricant and then you time how long the object takes to travel that set distance again. Okay, so that's kind of the overall idea of how you're going to test these different lubricants, is time how long it takes to get from one point to the next. So I've got my object up here, which is white, my start line and my finishing line. So I'll start the timer at the top black line and I'll finish it when the object reaches the second black line. Now I'll also make sure that when I tilt the tray up, it's obviously a set distance from the ground, which means that every single time I do the experiment, it needs to be a set height. Okay, this is a control variable to make sure that the objects are sliding down the same distance. Okay, so lift it to a certain height and you'll tilt and then let the object slide down. Okay, so that's the idea behind the experiment. So you're going to be drawing and writing for me a method on how you are going to do your experiment. So how are you going to carry it out? So you're going to be pretending like you're instructing someone else on how to do it. So a good way to do it is write your method, give it to your parents or a sibling, see if they can follow that method and understand what to do for the experiment. If they don't understand what to do for the experiment, then you can go back, add more information in, and then try again and see if they understand it then. So use bullet points or really short and sharp information. So step 1, step 2, step 3, and so on, describing how to do it. Include amount of things. So include, I don't know, the height you are going to lift it. So a set height. So whether that's in centimeters or whether the top of the tray is resting against something. Okay, it needs to be set exact things. Okay, a set distance and a set height for the tray. And then obviously don't forget your control variables. In the next slide, we'll discuss these control variables a little bit more. Okay, another suggestion I've got for you when using bullet points is your step 1 can just be to set the equipment up as shown in the diagram, and then using a pencil and a ruler you could draw for me a diagram on what you're going to do. So things to think about when you're writing your method. So how are you going to make sure that your control variables are not going to change? How are you going to make sure that the object slides the same distance each time? How are you going to make sure that the tilt on the tray is the same each time? How are you going to make sure that your object doesn't have a different amount of surface area touching the tray each time? You need to make sure that you're talking about all of these. Now, I'm not going to give you a method because you're at the end of year 7, okay? You should know how to write a method now, all right? Remembering it needs to contain lots of details. So you need to spend lots of time thinking about how you would do the experiment and how you would do each step. It might be worth running through the experiment and going, oh, actually, I need to describe this or I need to describe that. So get yourself a tray, get yourself something that you're going to slide down that tray and test it out. And make sure that the object doesn't roll either, because rolling will change your variables too much. Another suggestion is to repeat your experiment to increase the accuracy and also make sure that there's no anomalies. So I would suggest for each of your lubricants, I do the test 3 times and record those 3 timings. Okay, so for example, if you're testing with water, I test it 3 times and then get an average of those recordings. If, for example, my timings are 2 seconds, 2 seconds, 6 seconds, you're going to go, well, hang on a second, that 6 seconds is not correct. That is an anomaly. So if you remember from class, what you do with an anomaly is you record that set of data again. So you'll do that test a 3rd time, and hopefully you'll get 2 seconds, 2 seconds, 2.2 seconds, much closer data that 3rd test. Okay. Now, you need to do a risk assessment for me. Now, this is not a very dangerous experiment, but it's still good practice to do a risk assessment. So you can copy down this table and fill it in. I only want you to do 2 different risks. So what's the potential hazard? Who might be at risk? What's the potential outcome? Is the risk high or low? And action needed to avoid the potential outcome. So for example, if you're using a really heavy object, potential hazard is the heavy object falling on your foot. So who's at risk? You. Potential outcome, it might hurt your toe a little bit. Action needed to avoid the potential outcome, make sure that the object is not pointed at the end, the tray is not pointed at the edge of the bench. So even if it slides off the end of the tray, it just falls onto a bench, for example. And there you go, that might be one part of your risk assessment. So have a think, what other risks are there during your experiment? And make sure you're writing about them. So copy down that table and fill that out. Just fill 2 potential hazards for me. And then last but not least, you need to use a table to record your results. So I'd like you to test 4 different substances for me. I don't care what those substances are. Okay, have a think, have a look around your kitchen, or even your bathroom, for example, because you might want to try using soap or laundry, dishwashing detergent. There's lots of different things in your house that all of them might work well as lubricants. So have a go, but need to create your table. It's the last thing you're doing this lesson because it's where you're going to record your results when you do the experiment. So your left-handmost column is going to contain the 4 different lubricants you are using, and then you're going to have 3 columns after that. So test 1, test 2, test 3, and then you're going to have an average column. So sort of like this table here. So your table is going to look a bit like this. You've got your lubricant, and then test 1, test 2, test 3, and your average. So pick your 4 lubricants. Make sure you finished your aim, hypothesis, method, risk assessment, and you've got a table for your results. You're then ready to do your experiment. Now you can do your experiment today after this lesson, or you can do it tomorrow before you create a graph of your results. It's up to you. Remember, stay safe. Make sure you're talking to your parents, asking them what materials they can use, so you're not using their really expensive oil from Italy. Okay. Have a talk to your parents, get your siblings involved, okay, and just have fun testing out this experiment. I look forward to seeing all your results.